At first sight, the hypercar formula looks ideal for BoP, with predetermined aerodynamic performance and regulated power curves. But today I'm going to reveal something in the hypercar formula that a lot of people seem to miss. And this explains how Toyota was able to dominate in Le Mans again, after being balanced pretty well with the others in the races before. And how Toyota reaches the same top speed as the others while having less power. I've also come up with a good way to judge the BoP for an event, and the score system to estimate the performance target a car was built to, but more on that later. So, most people think that the aerodynamic performance window is very tight, thus there is no such thing as a car having less drag or more downforce than another, but this is false. And although the aerodynamic criteria are mostly hidden from the public, I managed to get these numbers. Max lift to drag ratio 4:1, downforce coefficient 5.2, and minimum drag coefficient 1.0, and one adjustable aerodynamic device such as a rear wing or front wing. So the ratio being there means that if you want 1.0 drag, your max downforce is 4, and if you want 5.2 downforce, you'll need 1.3 drag. Now I can guarantee you that the prototype rear wings can't increase downforce and drag by 30% from their least to most aggressive setting, not to mention the Peugeot that lacks a rear wing at all. So the designers of the car have to make a choice whether to go for a low drag, low downforce car, or high drag, high downforce car, or somewhere in the middle. And it gets more complicated. The 4:1 is the maximum aerodynamic efficiency, and there must also be a minimum in the rules, but it's not available for us. Jim Glickenhaus said that they sacrificed some performance for aesthetics on their 007 hypercar. And what I get from this is that the performance window is bigger than most of you think. And this means it's possible to have more drag and less downforce than a competitor. Going back to the fact that manufacturers have to choose whether to go for downforce or lower drag, I think Toyota has the least drag and Peugeot the most, with Glickenhaus somewhere in between. This was how Toyota had the same top speed as Glickenhaus at Le Mans, despite having 14 kilowatts less available to them. And I also think that Glickenhaus is very close to Toyota on downforce levels, I'll explain later. But I can already hear you guys screaming, but Peugeot has no wings, so how can it have the most drag? Anyone who understands aerodynamics can see that the front of this car is far from slippery, not to mention the massive gurney on the rear deck. Anyway, this prediction makes sense when we look at the Monza sector times. I am excluding the Alpine here because it was not built to the same regulations. Sector 1. This sector is basically a straight with a slow chicane. Top speed, acceleration and low weight are important here. And because the Glickenhaus got 20 kilowatts more than Toyota, they matched their top speed despite the drag. And a good top speed plus being the lightest car plus having the best power to weight meant that they were the fastest car in this sector, followed by Toyota with their good top speed and last Peugeot with their low top speed and high allocated weight. Sector 2 we have low to medium speed corners with a straight. Weight is very important, and this time a little bit of downforce comes into play as well. Glickenhaus comes first again. Their low weight does wonders here. Second Peugeot with high downforce, which isn't quite enough to overcome their weight penalty. Toyota is very close in third. Lower weight makes up for the lack of downforce, and this is Monza, so even in this sector their top speed helps. Sector 3 is composed of two high speed corners with a straight. Downforce, weight and top speed are important here. First comes Glickenhaus again. Because of their extra power they got, they were able to bolt on more downforce than Toyota despite their aero efficiency disadvantage. Plus their low weight is helping as well. Close behind is Peugeot. Their downforce is able to overcome the weight in this sector, but their top speed is still too low. Close behind them is Toyota. Their lack of downforce shows, but their top speed helps them stay close to Peugeot. Now, the reason I think Glickenhaus is a lot less efficient, especially in their lowest downforce configuration, is the Le Mans sector times. They did not excel in Sector 3, where the Porsche curves are, which are some of the highest speed corners on the calendar, despite weighing less than Toyota, but clearly had more drag than Toyota because they had the same top speed as them while having 14 kilowatts more to play with. I made a point system that judges the car's aerodynamic efficiency based on the BoP the FIA publish, because they're the only ones that know the actual aero numbers of the cars. I call it the Endurance Performance Points. And for Monza, this was the result. More is better, with Glickenhaus as a baseline. This makes total sense, as the Alpine is an old LMP1, and those were way more efficient than the current hypercars. Also, Toyota and Peugeot are very close, because they basically have unlimited budget compared to Glickenhaus. And you would expect Peugeot to be a bit more efficient as well, as they generate more downforce from the floor. From the Glickenhaus to the rest of the field does look like a big jump, but at Monza the Glickenhaus was also a bit too fast with its current BOP, and I suspect it will be slowed down for the next event. At Le Mans, the score from Glickenhaus to Toyota would have been 70, and that already makes more sense. Now, with these different downforce and top speed levels, do you give the high downforce car more weight and more power, and the low downforce car less weight and less power in an effort to match the sector times? Or do you let them be strong in their own areas and make sure the lap times only match? The first option punishes the high downforce cars on tire wear and fuel consumption, so this does not look like the right way. And the latter option requires a lot of BOP changes between events, as the low downforce cars will always be faster at tracks like Monza and Le Mans, and the high downforce cars at tracks like Portimao and Sebring. And looking at the BOP history, the ASO does not like a lot of BOP changes between the real hypercars, Toyota and Glickenhaus. This could be a problem, as requiring more changes between the tracks means worse chance for a fair BOP, especially when the ACO and FIA don't have the data of a car on a specific track, which will be more than half of the cars next season. Together with the Endurance Performance Points, I've created a new rule to judge BOP, the Endurance 0.5% rule. After enough races with these data points, we should be able to predict the BOP for the next race, and see what the ACO does with the actual BOP, which will be quite fun to compare. Anyway, so the 0.5% rule works as follows. It can only be applied after a race event, because it's based on the ideal lap of the cars during the race, as those are often very close between teammates, often within a tenth. And for a good BOP, all of them must be within 0.6% of each other, and for a good BOP 0.4%. For reference, this would mean that Toyota and Alpine were near perfect at Monza, which for anyone that didn't see the race was indeed perfect. Toyota and Peugeot were good at Monza, which was also true as Peugeot managed to hang on before they had their issues. Glickenhaus and Toyota were perfect at Spa, which was also true because they remained very close until the rain came in. I hope you now have a better understanding of the hypercar regulations and why balancing these cars out is harder than expected. Soon we'll be able to predict our own BOP with my data points. I'm actually thinking about making a balance of performance prediction competition in the future, where you guys can participate in as well, a bit like in F1 Fantasy League. Anyway, we are still on our way to the golden era of sports car racing, and I'll keep you guys updated on the insights and the rules of the balance of performance, so make sure you stick around for those. And if you want to be updated on hypercar news on a daily basis, make sure to follow Le Mans Hypercar News on Instagram. It's not ours, but it's a very good page. This was Endurance, see you in the next one.